Why do most power system studies done during design fail to hold up during live operations?
This has been a problem which we faced multiple times, and we have done a number of power system studies post-mortems, if I would call them, to find out the root cause behind this. And the number one reason that we have found is that the assumptions which have been made during the design stage, they a lot of times do not survive contact with reality. Some of the reasons that I can enumerate which can cause this, one is your inaccurate input data during the design phase. That leads to a number of inconsistencies while you are doing the modeling, and it causes different outputs which are very different when it comes to your operational stage of the data center, or be it any mission critical facility. Example, your nameplate ratings versus your actual ratings of equipments. Guesstimating of future loads. You're doing a lot of estimations on the future loads that are going to come in the facility in the future. Those do vary based on real life conditions. Next is if you're commissioning in phases. What happens is a lot of times you have certain temporary feeds. So the source side fault level changes. You have differences in the protective device coordination because of that. Short circuit levels will change because of that. You have certain temporary loads which are running, like your welding loads. You have certain transformer switching happening, your load banks, you have certain motors. So all of these have, say, certain transient characteristics which have not been factored during the design stage. Tie incomers maybe, which impact the fault levels. Third, I would say, is your differences between your real world versus your technical design specifications of equipment. So your real world data, when you really compare of, say, generator characteristics, your transformer Inrush characteristics, generator decrement curves, force feeds, and so on. These all will make a difference when the actual equipments and DDSs are verified and the installation is done, the measurements are done. Example, Harmonics, if I take another case. That also will play a big role because the OEMs will provide you a lot of higher order harmonics as part of the spectrum for you to map during the modeling stage. But the real world harmonic spectrum will vary, and that will cause a different impact in terms of the harmonic resonances and so on. Fourth and most important, I think, is the protection settings. Here there are a lot of limitations when it comes to device duty, short circuit levels of switchgear, and those will affect the way in which protective device settings are set on devices. Even the trip units, that is one of the major reasons we find during the on-site validation of the settings that we do. The trip units, even if say micrologistics is selected, but on the site when you go, you will find there are different versions of that, and the settings which have been done during the design stage rarely is matching with what the actual breakers have been installed. Changes in CT ratios, that also happens. Dual tap CT ratios and all are being selected during design stage. What has been finalized during operations or during commissioning is different. So all in all, this is a very pressing issue, and our only recommendation is to ensure that every mission critical facility always goes through a second power system studies, especially your short circuit, load flow, and your protective device coordination once it is fully commissioned to its full load normal operation.